Good morning. Thank you for joining me today. My name is Danilo Seskar, and in this presentation, I'll be talking about prebiotic chemistry and how it relates to different hydrothermal events. And in this presentation, I'll be piggybacking along the research and studies we have done this semester. So bear with me if I fail to explain something. So first, I'll be talking about the origin of life, where it is believed to have occurred, and the theories behind it. I will then be discussing the different type of hydrothermal vent systems that exist, and how each of these systems have the necessary components for organic compounds to be synthesized. So the origin of life on our planet is believed to have happened millions of years ago in an environment drastically different than what it is today. So the environment where life was theorized to come into existence was called the primordial soup. So the primordial soup is a term used to describe a liquid environment composed of a high diversity of inorganic matter in a fashion similar to that of a bowl of soup. And from this primordial soup, the first organic compounds that were believed to have been created were amino acids. And there are many theories as to how these amino acids were formed. So the two theories that stick out the most are the gene first theory and the metabolism first theory. So the gene first theory suggests that in the primordial soup, there was a time when the perfect conditions existed, be it the temperature, the amount of inorganic material, etc., that the perfect conditions existed for the inorganic material to be synthesized into organic compounds. So what's different between the gene first and the metabolism theory is that the metabolism first theory suggests that it wasn't just a random chemical process with the right conditions, but that there was a rudimentary metabolic process that existed that allowed for organic compounds to eventually be created. So, how does the origin of life relate to hydrothermal vents? Well, it's believed that the conditions that exist at hydrothermal vents were representative or are representative of the environment that existed millions of years ago. As we know from our studies this semester, hydrothermal vents spew out inorganic material, but the organisms around these vents are able to utilize these materials to create energy and sustain themselves. So, unlike photosynthetic organisms that exist today, again, hydrothermal vent organisms, especially in submarine hydrothermal vent systems, cannot utilize sunlight. And like the chemosynthetic bacteria that we see, the oldest fossils, uh, those that are about 3,500 million years old, were believed to be chemosynthetic bacteria that were created from chemical processes in the primordial soup. Researchers also believe that in the primordial soup, it was a water-based system that allowed for chemical processes to occur, that allowed for organic compounds to form and eventually create the first organisms on our planet. So there are three different types of hydrothermal vent systems that I'll be talking about today: subaerial, submarine, and impact crater systems. The two characteristics that these three systems have is that they all have a heat source and a fluid phase. So the heat source refers to the energy needed for chemical processes to occur, and the fluid phase refers to the introduction of inorganic material into the system that allows for chemical reactions to occur. So first, I'll be talking about submarine hydrothermal vent systems. As many of you know from our studies this semester, submarine hydrothermal vents exist deep below bodies of water. These systems are most likely to suspect for the emergence of life on our planet. These systems spew out the necessary materials from the Earth's core needed for inorganic to organic synthesis, and the energy from, again, the heat from the Earth's core needed to perform these chemical processes. There are many minerals that spew out from these submarine hydrothermal vents, such as sulfur, copper, iron, zinc, magnesium, amongst many others. And these minerals are used by primarily autotrophic thermophiles to create energy needed for all other organisms to survive in these systems. So these minerals come out from two different types of vents, two different types of vents, black smokers and white smokers. So the difference in their naming is simply due to their coloration. Black smokers are more dense in material and causing them to have a darker color than the white smokes. And they're also closer to the heat source in the form of the magma from the Earth's core. And because of this, black smokers have a higher temperature gradient, going up to about 400 degrees Celsius, whereas white smokers only go up to about anywhere between 75 and 90 degrees Celsius. Now, submarine hydrothermal vent systems, the vents themselves start out as black smokers. There's high density, high heat, in the initial stages of post-volcanic activity. And over time, they are replaced by white smokers because the density of the minerals is depleted, and so is the heat source. The second type of hydrothermal vent system that I'll be talking about are subaerial hydrothermal vents. Now, these subaerial hydrothermal vents can also be called hot springs, or they're commonly found as hot springs. As in its name, subaerial hydrothermal vents exist above sea level, but there are still water-based systems with a heat source from volcanic activity. So these systems, like submarine hydrothermal vent systems, have big temperature gradients, which are all necessary for different chemical processes to occur. They have also volatile content, pH, and redox potential. And again, these are all necessary for these are all necessary chemical components necessary for organic compound synthesis. So what's interesting to note about these systems is that although submarine hydrothermal vents are attributed to be the most likely suspect for the emergence of life, subaerial hydrothermal vent systems have a direct pathway for organic compounds to be dispersed along terrestrial bodies. So it is believed that photosynthetic organisms are more likely to have been created from these subaerial hydrothermal vents, where there is more access to sunlight than there is in submarine hydrothermal vents. And to end off with the different types, there are impact crater systems. So impact crater systems are created when large asteroids at fast speeds create cavities called craters on Earth and other solid bodies in our solar system. When an asteroid impacts Earth, for example, the minerals around the impact site are vaporized and dispersed, and also any extraterrestrial compounds found on or in the asteroid are introduced into the surrounding. So what's interesting to note, and it's different than the gene first and the metabolism first theory, is that there's also another theory that suggests that organic material came from outside Earth, and the likely suspect for introduction of these organic compounds into our planet is through asteroid impacts. And what's interesting is that out of the 181 confirmed impact craters, 60 of those have been found to have created hydrothermal vent systems, both submarine and subaerial. What's also interesting to note is that these are also found, again, on Mars and Europa, and they also have been found to create hydrothermal vent systems, which alludes to the possibility that impact crater systems have the necessary chemical and physical requirements needed for organic compound synthesis to occur. So the minerals present in these hydrothermal vent systems are all required for chemosynthetic processes to occur. The different sulfides, oxides, sulfates, carbonates, etc., that are all found at these sites. And as we know, different organisms use these chemical compounds to create energy. Wrapping back to the discussion of the origin of life, these compounds were discovered to be present in Earth's primordial environment, which leads researchers to believe that the prebiotic processes that need to occur for the synthesis of organic material occurred at these hydrothermal vent systems, subaerial, submarine, and impact. So on top of the necessary minerals for prebiotic processes to occur, hydrothermal vents have the right physical, chemical, and geological conditions for organic compounds to synthesize and evolve. So the energy required for these chemical reactions comes from heat energy, be it volcanic activity or fast, high-speed impacts from asteroids. And the high mineral density that allows for a diversity of organisms to capitalize and utilize different chemical processes to sustain themselves. These hydrothermal vent systems also have a temperature gradient that allows for different types of chemical processes to occur at different stages. Those that require intense heat and others not so much. There's also a constant supply of hydrogen, and for those that haven't taken organic chemistry, hydrogen is a key element necessary for organic compounds to exist. So to conclude this, hydrothermal vents are very similar to the environment where life originated from, or where it's theorized to originate from. The prebiotic processes that occurred were allowed to happen because hydrothermal vents had the correct chemical and physical requirements, heat and mineral diversity. So while this is all true, it is only in theory because, unfortunately, only simulations and observation of modern day hydrothermal vents can happen. We unfortunately cannot go back in time to see what actually occurred. So the search for the origin of life is still very much ongoing. And an exciting prospect of research is that we can observe life existing on other planets potentially, like Mars, where similar to Earth, there are hydrothermal vents with the same chemical and physical properties necessary for organic compound synthesis to occur. So thank you very much for your time today. It was a pleasure presenting this topic. Here are the references used to present this material, and I hope you all enjoyed this presentation. Please feel free to ask questions, as I'll be more than happy to try to answer them.